Hello again and welcome to this lesson. We're going to have a look at factorizing the sum and the difference of two cubes. Now you might recall before we've shown you that a cube is a number or any value that is multiplied 3 times by itself. So something like x to the power of 3 means this is x times x times x. Now if we talk about the sum, we talk about addition. If we talk about difference, we mean a subtraction. Now the sum and difference of two cubes means there's going to be two terms and both terms are going to be cubes. So a basic example would be something like x cubed minus y cubed. That is the difference of two cubes. Or we might have something like, and this might look a little bit confusing, z cubed plus 1. And you might say, but 1 is not cubed, and I'll say, but you're wrong. 1 can be written as 1 to the power of 3. 1 to the power of 3 is equal to 1, so 1 is equal to 1 to the power of 3. Okay, 1 times 1 times 1 is 1. Okay, another example. And now here it's again going to be very important, and I do encourage you, if you don't know this list, do go and study it off by heart. Then know all the cubes and all the perfect squares as well. Perfect squares is 1 times 1 is 1, 4, 9, 16, 25. These are the numbers that I get when I multiply the counting numbers by itself. Okay, so if I multiply these ones again with a 1, a 2, a 3, a 4, I get the cubes. Okay, so basically I'm just doing 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, 10 cubed is 1000. Okay, now this is going to be important so that I can recognize the difference of two cubes. So for example, if I gave you 27 minus let's say 8x cubed, you will notice, oh, this is the difference of two cubes. How do you know? Well, because this is actually 3 cubed minus 8 is actually 2 cubed, and x already has its cube. Okay, so that's first of all how I'm going to recognize what is the sum and the difference of two cubes. Okay, now before we go ahead, it's really fairly simple. I don't think you'll have a problem with it. Let me just quickly show you the mechanism behind this. Okay, imagine I had a bracket like this, a smaller bracket. Okay, and I have a larger bracket here with 3 terms in it. Okay, here, okay, I want my answer in the end to be x cubed plus y cubed. So I'm just trying to show you how I'll have to simplify this in order to get that. Okay, so obviously to have my first term, the x cubed term, I'm going to multiply x with x squared. Okay, and to have the last term, I'll have to have a y cubed. For these two, for the sign of this last one, this positive y, this sign times that sign must give me a positive. Okay, which if this is a positive, then that must also be a positive. If this is a negative, okay, here, and then well, you'll later learn that if this is a negative, then that one will also be a negative. Point being that this last term here will always have a positive. Okay, and this middle term here is going to cause a little bit of a fuss, because if I'm trying to multiply this out, okay, I'm going to actually get 2 terms times 3 terms. I'll end up having 6 terms. So I want this middle term to cancel out with all the other terms, and the only way that's possible is if this middle term has a different sign than there. So in other words, this is a negative, because this one is a positive, and the middle term is the product of these two terms, x times y. Let me show you that it indeed does work out. Remember, when I multiply a binomial with a trinomial, what I do is I multiply each term in here with each term in there. So I've got an x times x cubed. Okay. Well, actually, let me do the method I most prefer, and that is actually just normal distribution. I'm going to distribute this whole bracket to every term in there. So I'm going to have x plus y times x squared plus x plus y times, and remember this time it's a negative xy, plus, and now I'm distributing x plus y to the last term, which is positive y cubed. And now I distribute back, okay, from the back. So I get x cubed plus x squared y plus, now I multiply this in, okay, which actually makes that one a negative, because I'm multiplying with a negative, negative x squared y, and then negative xy squared, and then this last one positive, and sorry, this is not cubed, that's to be square, sorry about that. Y times y squared should give me that y cubed, so this should be a square. I do apologize. Okay, so when this y multiplies there, I get xy squared plus, and then y times y is y cubed. Great. Okay, now, and just notice how here I've got an x square y, and there I've got an x square y. This one is positive and that one is negative, so they add up to 0. Here I've got an xy squared, and there I've got an xy squared, and one is negative and one is positive, which again adds up to 0. So I'm left with x cubed plus y cubed. Okay, so basically let me summarize what we've just seen. Okay, first of all, and now the idea is I want to go from this direction into that direction. I want to have the sum or difference of two cubes, and I want to factorize it into brackets, okay, which first of all you make two brackets. Make two brackets. Okay, a small one that will take two terms, and a larger one that will take three terms. Okay, so if I have x squared, and let me write it like this, I'm going to do x cubed plus or minus y cubed. So I'll make a small bracket and a larger bracket. The small one should be big enough to take two, the large one big enough to take three terms. Okay, step 2, the sign in the smaller, bracket, let me do it like that. That would mean the smaller bracket, and that would be the larger bracket. The sign in the smaller bracket is the same. Okay, which means if I've got my small bracket, the sign in here, if that one is plus or minus, this one will be plus or minus. Okay, so basically what I'm saying is if this one is x cubed plus y cubed, this one would be whatever plus whatever. Okay, if it was x minus, it would be x minus. Okay, so third step, take the cube roots of each term in 2. Suppose not take, let's say place the cube roots of each term in the smaller bracket. Obviously I just forgot to still keep my larger bracket here. I still have that larger bracket, just haven't started filling it in yet. Okay, so if I have x cubed plus y cubed, I'll take the cube root of each of those terms, which would be x and y. Okay, so my first term would be x plus minus y. Okay, basically I'm just getting rid of the cubes, but you'll see later on it might be a little bit more difficult if it's something like x to the power of 6. Okay, and then I still have my larger bracket. Now we're about to fill in the larger bracket. Okay, the larger bracket, okay, the first term in 3, that's the larger bracket, is the first term in 2 squared. Okay, so basically what I do for this first term is I just square that first term. So if I have x plus minus y, then this one would be, the first term would just be that term squared. Okay. Next, sounds like a lot of steps, but it's really simple steps. Okay, the next step is the first sign is opposite this sign in the smaller bracket. So in other words, this first sign I'm going to get here will be the opposite of whatever sign is in there. So in other words, x plus x plus minus y, this one will be x squared. The first sign now would be opposite. So if this one is a positive, this one would be a negative. This one is a negative, this one would be a positive. So x squared opposite whatever is there. Okay, and the next one is the middle term. Okay, the middle term in the bigger bracket is the product of the terms in the smaller bracket. Okay, so this middle term, we already know the sign is opposite that sign, but the value or the actual term is the product of those two, which means that this is x plus minus y, x squared minus plus, because the signs are different, and now the product x y, just multiplying those two terms with each other. Okay, and then the last term, okay, the last sign, let's first do the sign, is always positive. Is always positive. Okay, you might understand later why. I'll try and say that again. I have said it, but I'll say it again. The last sign is always positive, and the last term is the square, right, like that, of the last term in the smaller bracket. Okay, does that make sense? So I'm basically, just close this bracket. Okay, I'm basically saying that x plus minus y, x squared minus plus xy, the last sign is always positive, and the last term is just this last term squared, so y squared. Okay, and there we go. Okay, so I promised I'll tell you why is this always a positive, because remember, to get the last term, the y cubed term, we said that this sign here, is the same as that sign. So if this one is negative, and I multiply this term with that term to get my y cubed, this one will have a negative, causing this sign to change. which means that when I multiply it out, I hope you understand what I'm saying, but if I multiply them out and this has a negative sign, this one can't be the same as that one, okay, because I'll get a different answer. The negative will change it, so this one will always be a positive. Hopefully that makes sense. But let me do 2 examples. I'll try and do a little bit more complicated examples. First of all, a very common one, something like x cubed minus 1. Okay, so we said we're making 2 brackets. I'd suggest you first write all of your numbers. If you've got any numbers, write all of the numbers as something cubed, like 1 is actually 1 cubed. Then, as we said, in the first bracket, it's exactly the same, but without the cubes. So we take the cube roots of every term. So this is x, the sign stays the same, minus 1. The first term we said is this first term squared, so x squared. The next sign is opposite that sign, positive. The middle term is the product of x and the last term, of the first term and the last term, which is just 1 times x is just x. And the last term is simply, will always be positive, okay, and the last term itself is actually this number squared, okay, that number squared is 1 squared is just 1, okay, well, I think it's very simple. So let me actually make it a bit more complicated. Let's take something like 18 x to the power of 6 minus let's say 54. Okay, now one thing you'll notice that neither 18 nor 54 is one of these numbers. Okay, they are not cube numbers. But what I hope you did see is that I can actually take out 2 as a common factor. So please remember that there's an order in which we factorize, and the first thing we always do is look for an actual common factor. In this case, it is the number 2 can be taken out as a common factor, and then I have 9x to the power of 6 minus 27. Okay, and 9 and 27 can both be written as cubes. 9 is the number, that I'm lying. 9 is not. Let's make it rather 16. I made a mistake. That was silly. Okay, let's make this 16. Okay, make that one 16, which isn't a cube, but when we take out a 2, it's 8, which is a cube. Now the cube 8 is 2 to the power of 3, and now you might get a little bit confused, but what about x to the power of 6? Well, I suppose I can write it as x squared to the power of 3. If you know your exponential laws, this will make sense. Okay, x squared to the power of 3, but I'm just going to leave it like this for now and just show you how we will deal with them in just a minute. Okay, minus 3 to the power of 3, that's 27. Okay, so how would we do it? Well, sorry, I should write it here. We'll first keep our 2 because it's still a common factor. It stays a factor in the beginning. We have a small bracket and we have a larger bracket. In the smaller bracket, we said we'll leave it exactly like that with the same sign, but here we've got a little bit of a problem because this is to the power of 6, not to the power of 3. Well, all we're really doing is actually dividing all of the exponents with 3. So this is 2 to the power of, look here for example, 3 divided by 3 is 1. 3 divided by 3 is 1. That's what we do when we take a cube root, is we divide the exponent by 3, and that's why I said that the first the terms are the cube roots of the original terms. So the cube root 2 to the power of 3 is 2, the cube root of that is 2 to the power of 3 divided by 3, which is 1. X to the power of 6 divided by 3 is 2. 3 to the power of 3, and remember the sign stays the same, the 3 divided by 3 is 1. I don't need to write the exponent when it's 1. Okay, first term in here is this term times itself, this term squared, which is 2 times 2 is 4. X squared times x squared is x4. Okay, the middle term is these two terms. First of all, the sign is opposite. If this is a negative, this would be a positive. The middle term is the product of these two terms, which is 2x squared, times the 3, which would give me 6x squared. And the last term is simply this last term actually squared. Always a positive, but 3 squared is 9. And now one question that I remember I always asked my teacher, or at least asked them, is that I recognize that this looks like a normal trinomial, doesn't it? Look, it's a trinomial. If we go back to this one, it's a trinomial. And yes, it is a trinomial, but it is a non-factorizable trinomial. It would never, you'll never be able to factorize this one into two perfect brackets. Okay, so you can be very certain that if you have factorized, taken out a common factor in the beginning, and you find that you've got the difference or the sum of two cubes, after you've done this method that we've just looked at, you will have completely factorized all of the terms. Well, I hope you are happy with what you just saw, and that you actually find it's not very difficult. Good luck practicing this on your own. Cheers.